the state of denial being rolled back in a way. I mean, on its last legs. Do you feel there has been
in
a
Italy
change
in the last
recently?
3 years decreased a lot the speech.
No new arguments?
Maybe.
Well, there haven't been any new arguments for decades. But denial as a public thing is very much tied to the political context. If there is a political party that sees some gain in kind of stoking this, then it will come back again. These things don't come and go because rationality has prevailed and people have changed their minds. These things are always there, and whether they get a lot of public attention is mainly a function of whether people who have the ability to shift the public conversation focus on that or don't. So in Europe, they generally tend not to focus on that, and so it's a smaller issue. In the US, we have one party, half of which has decided to focus on climate change as one of their kind of issues against the liberal elites, against Obama, and now
against taxes,
against anything, yeah, and so it's become part of that. But it's not that all of these people have looked at the science and come to their own conclusion. It's become part of a package.
Don't you think that maybe because the people realize that maybe something is changed, they see the heat waves, they see the increase of flooding? Don't you think that maybe some sign of the nature
they see
maybe
in our latitudes?
Right. So I think there's a bigger impact of current weather on people's attitudes towards climate change than there should be. Yeah. So if it gets cold, they say, "Oh no, it's not real."
Right.
If they say, if it gets warm, they say, "Oh, this is global warming," and neither of those reactions are really very sensible. But actually, it's a bigger impact on how people think about it than you would think.
Here, the people see the glaciers on the mountains, on the Alps, so there are a few signs that people could...
And droughts. And recurring droughts, which we didn't have so much in southern Europe.
Right. So, and sea level issues, particularly here in Venice. We've got Venice sinking and the sea level rising, so that makes it doubly bad here. And people can see that just a little bit of a change makes a big difference, and a little bit more makes an even bigger difference. So, people can see that damages go up, very, very strongly. As a function of small changes in the base climate, and that's not a hard thing to get people to understand. But if you had another cold winter, and you will have another cold winter,
we had a cold winter, but this cold winter, the people didn't react as 3 years ago. They say, okay, it's cold winter.
Let's wait. Yes, let's wait.
Yeah.
So they change. In Italy, I've seen that something has changed.
And, mostly the public conversation changes as a function of political leadership. So if the people in charge take a leadership stand on this, they have to be talking about it all the time, but if they take a leadership stand, then that kind of percolates through. It's when people kind of are running scared and don't want to talk about it, then that lets the more extreme voices on both sides or on all sides kind of dominate the conversation more. So it's it's not as simple as there's just one arrow and it goes towards that and it comes back again and it goes. It's not. It's more complicated.
One more question. I change argument. About the problem of runaway greenhouse gas effect. Jim Hansen in his last book say that if we burn all the fossil fuel, the runaway greenhouse effect is certain. So there will be some.
There might. He says may.
So burning all of the fossil fuel on Earth is an enormous amount of carbon. Yeah. Absolutely enormous. Whether we're, that's much larger than anything anybody's projecting for 2100. There's some theoretical things that say, well, we're not going to go into a runaway greenhouse effect like Venus until the sun becomes a red giant, which might happen in 4 billion years. But I think Jim's point is far more. It's kind of metaphorical rather than practical. I mean, like the practical chances of us becoming like Venus anytime in any of the next centuries is zero.
Or in this millennium.
Yeah, in the millennium, who knows what might happen? I mean, like,
so millennia, Venice 1 millennia ago was here,
That's true.
Millennia, not so much.
Yeah, well, I mean, to my mind, that's a long time. But it's as a serious thing that people need to worry about. It's not a serious thing that people need to worry about. Is the fact that we're pushing the climate into states that haven't been seen on this planet for hundreds of thousands of years, millions of years, perhaps. I think that's very important.
That's enough,
and that's fine. That's okay. You've got me right. That's totally enough. I don't think we need to. We don't need to add to that to make it.
And that's where he comes from, no? From other planets' climates, let's say atmospheres. So I think people have the imprint of what they start studying first. Probably you would recognize bad math, even in a completely different field. No?
Maybe.
The way he has Venus in his sight. Because he started there.
Yeah, I mean, you'd have to ask him. I couldn't say.
No?
Okay.
Okay. No, I'm sorry. If you had a magic wand and you could do at Goddard what you want, I mean, have the biggest computer in the world or a massively distributed computer, all the data, what would you start with?
I think we would, if I had a magic wand, what I'd really like to see is a better way of accessing the data that we have. I mean, right now, analyzing the data, comparing it to the observations, looking for events, it's really hard, and it shouldn't be that hard. We have, petabytes and petabytes of model output and petabytes of remote sensing output, and we're not making the best use of the data that we have, right? We're not doing the best that we can do at looking at how the models are doing for this event or that event, or when this happens or when this is connected to we're not able to do that effectively because the data is sitting here, the observations are sitting there, and like just bringing them all together, downloading it's the work of years because there's so much information.
You need an information analysis strategy.
We need an information analysis strategy. We need to build.
It's the same in neuroscience. It's the same in genetics.
Well, then it's a common problem, and maybe my magic wand could help them as well. But what we really need to have is to get away from the idea that data archives are just there to give people data. We need to move towards a more dynamic concept of data where, the data sits somewhere and then you can have calculations done, you can do analysis, and then you only download what it is you actually want. And you have the whole thing kind of like sitting in the cloud that's using spare cycles everywhere, but it's sitting where the data is, right? Because right now the biggest bottleneck is bringing that data down, right? You're thinking, okay, well this video is slow coming from YouTube or something. Okay, well just think about that video, times it by 1 million, and then wonder why we're not doing that analysis on our home computer, right?
So, and who could do that? Google? No.
You know what? Google could do it, Amazon could do it, NASA could do it, NOAA could do it, but we just need to do it. And and I'm pushing a number of initiatives at NASA and at NOAA and at DOE to try and get this to work better. But it's hard. It needs to be built. It needs to be designed properly. So we're kind of working towards
it. It's true, all areas. Avian viruses, whatever. Every scientist you talk to who's doing models says the same thing.
Well, the problem is that our ability to collect data and to generate simulations is increasing exponentially. Our ability to download data is only increasing very slowly. And so we need to have, already, we have more data than we can download. So already we see that there's a need for a new paradigm for how we deal with data analysis and data synthesis. And you're right, that's, it's not just in climate science, right? It's everywhere. And so it is a much more generic problem than just my problem, which means that it might actually get fixed by people who know what they're doing. So.
No, because if I were NASA, I would start a new institute. I don't know, but I'm not.
So I am, and so that's what we're trying to push.
But I think it's a really common problem. You know. No, basta. No,
Okay.
Thanks.
Thanks, Gavin.
Okay, well, thank you very much. It was a pleasure talking to you.